That's just the design of this lesson. And it's one of mine. And I'm going to start from what we did last time. And I'm going to do a really rough drawing. This is a transformer. You have coils and coils. This is the number of primary coils. This is your primary side. So let's write that. This is your primary side. Primary going in, secondary coming out. Okay. So NP stands for number of primary turns in the coil, and here we've got number of secondary turns. So in an ideal transformer, we've got voltage in, so we've got voltage going in and voltage coming out. So this is voltage in your primary going in and voltage in your secondary coming out. And the equation hasn't come out very nice. So we've got voltage in secondary divided by voltage in primary, and we did that last week, equals number of terms in secondary over number of terms in primary. And that's it written there. So now I want to add something else to it. That's a little bit of last week. And I want to add something else to it, and it was this. Ideal power. That just means you don't lose any to heat. All right. So let's play with this. Let's talk about this. From last year, I'm going to change colour. I'm just going to move over here so you can see where my head's thinking. Right. Power equals voltage times current. Okay. So as we said, the power in, and let's see how, yeah. The power in your primary is equal to the voltage in the primary times your current primary. Okay. Now, power in your secondary is equal to voltage in your secondary times current in your secondary. Now here comes a tricky bit. What is, and this is understanding what I'm saying. The power going in your primary is the same as power going in your secondary. This is your power in your primary. P is the same as this. You know, in primary schools, they tell you that means equals. You get used to saying equals. It doesn't mean same as. So power in primary is the same as voltage in primary times current in primary. Voltage in secondary times voltage in secondary is the same as power in secondary. So that's where they've got this one, power equals voltage times current. That's where they've got this bit for. I'm really not going to look at that. That's just rearranging stuff. We're not going to look at that. We are going to look at this. Right? Power loss. So the loss of power is equal to I, this is your current, squared R. So as much as I've explained this, right now there are three equations you need to know. That one, and that one. Okay. All right. And the key out efficiency. Now this looks really complicated, and I'll explain it to you. That's your fourth one. Efficiency. All right. And I'll write it in shorthand. Efficiency is how much power you put in. No, I don't like it that way. Power out divided by power in. No, I didn't like the way they did it. Times 100. Because it's a percentage. Percentage efficiency. All right. And that's your next one. So you got what? 1, 2, 3, 4, 5 formulas. all there for you. Key ideas. Transformers need AC, is the current switching backwards and forward. All right. Step up, increase voltage. Oh, that's zoomed out there. Let's go again. Step up. Let's write that here. Step up, increase voltage. Step down, decrease voltage. All right. So that's it. You use the formulas to do your calculations. Core facts and quick wins. Yeah, it isn't. It's just hard. What does a transformer do in one sentence? For me, this is you word it in your own way. Transformers either increase the voltage or decrease the voltage. Why must transformers use AC? Because they need a changing magnetic field. Define step up and step down transformers. Any way you want. Step up increases voltage. Step down decreases voltage. Number 4, you have to find the formula that works. You've got MP, NS, VP, VS. It is, oh God, I can't even see it. This one here. That's for number 4. We did those last week. Sub your numbers in, find it. Same one for this. Have a think. You've got VP, IP, VS. This is the power one. VP, IP, VS. Oh, and you know what? I was so busy talking. I put a VS twice. That should be IS. Okay, I stands for current. I'm just going to put that in there, especially if you're new. I is a symbol for current. So I've thrown so much at you guys. And I said to you, this is going to be tough. It's going to be ridiculously tough. And I want to see at what point you just go, do you know what? Oh. Now, I've talked you through. Now, be careful with 5 kilowatt. Watt is the unit for power. W equals power. You cannot work in kilowatts. You must change kilowatts to watts. And you do that by times and by 1,000. So this one is actually 5,000 watts. Ignore 9. I don't need to do 9. I'm not going to talk for so long. Okay. That's your task. You've got to answer all the questions. And that's mean. Right? In every possible sense, that is just tough. Listen to my work. Yeah.